This is Karen O'Brien with FLO-2D Software, and I'm going to cover the process of turning real-time NexRAD rainfall data into spatially variable gridded rainfall data that would be supported by FLO-2D. So basically we're going to use the NexRAD data to create a raincell.dat file. So I want to start by the project setup. Now, you don't want to do this procedure on your complete project, because it takes basically what happens is as soon as you have that raincell.dat in this system, it will then have to export it every time that you export your project, and that file can get really big and it can take a long time to export. So I like to perform this procedure on just a skeletal project. So the skeleton project is nothing more than the computational domain from the baseline project, so that the grid numbering and spacing is always the same, and the have to create a grid. So the computational domain, create the grid, and that's all you need. The next step is setting up the data and getting ready to run the rainfall editor. So a couple of things I wanted to point out: that the user's manual will outline this process and is updated with all of the information that you need. So it gives you an explanation of what you have to do. So you get a series of these .asc files, ASCII files, and a rainfall catalog, and you have to set that up in order to import and interpolate the data. So the rainfall catalog is very simple. It's start time, end time, time interval, and the ASCII file count. So here we go. Start time is the date and time. End time is the date and time. The interval is 5 minutes in this case, and the rainfall count is in this case there are 239 ASCII files. So that's important so that the raincell.dat is set up correctly, because all of this data goes into the raincell.dat file. Originally in the GDS you had to also have a list of all of these files in the rainfall catalog, but in QGIS you don't have to have that list of these files, because what QGIS is going to do is it's going to read every file in the folder and take it. So here's just the sample of the data. Now I'm going to take this same process and I'm going to show you the data that we will use. So what I've made is this is just a short, simple sample so that it doesn't take too long to calculate. And what it has is all of the rainfall catalog and all of the data starting at time 0005 minutes and up through 2 hours and 25 minutes. So let's take a quick look at this data so that you can see how it's set up. So here is the rainfall file, and as I said before, you don't need this, so I'm just going to take these out and delete them, and then make sure that I have the right number of files, so there are 29 files. And let's just come over here and count these. If I select them, I'll be able to count them. And you can see that I have 29 files. And then I'll click Save. Now what the QGIS is going to do is going to take each individual one of these, import it based on how it's sorted by name. It's going to import the data, interpolate it to the grid, and then remove it from the map. So you won't really see this. It happens kind of like in the background. But I want to show you what the data looks like. So if you import the data onto the project, actually let's do that, and let's open the data file in the text editor so you can see what the data looks like too. So ASCII data is always just the text data. Kind of represent a raster. So it has the number of columns and rows, the pixel, the lower left corner pixel, centroid of the pixel is this coordinate, this XY coordinate, and you have to convert all of your data to your project coordinates. So for example, most of your NexRAD data is going to come as lat long data, WGS 84, so you will have to convert it to your coordinates. In this case of state plane, my coordinates were state plane, and there's a lot of these files, so you'll have to convert in the actual project. There are 289 files, so you do a batch conversion in this and convert all of these, the coordinate system for all of those probably can do that in ArcGIS easier than in QGIS, because ASCII grid files are kind of an ArcGIS thing anyway. Then you get your no data value, cell size in feet, and the rainfall information is in inches. So I'm going to move this out of the way now. So you can see here that there's 0 inches for most of this data in this 5-minute interval. And for our project area, it's pretty much 0 for the whole interval. But if I zoom to the layer, you can see that there are some 0.164 inches of rainfall over this 5-minute interval on our map. And if I put this down to the bottom, you can see that here's our project area compared to the map. So this is the whole map, basically the whole map of Phoenix, and this is the whole Phoenix storm. So I pulled another one on here. Let's see, I can't remember when the storm peaked, but if I can pull another one on from the lesson data, let's try, I think the storm peaked kind of in the morning. So let's try this. Yeah, there we go. So there's some project, or excuse me, some more data of the storm coming through. And this is a calibrated NexRAD data set. So what it is reflectivity data that was calibrated to gauges. So it's calibrated data downloaded from the NOAA site. And this is the real storm. Let's see what we have here. And so if you were to load all of those, you could probably animate them so you could see the storm moving across the area. Anyway, we don't need to do that because we can just remove them. We don't even need them to be in our map space to use them. So I'm going to remove these layers. And instead of importing the layers, I will just run the interpolator and it will process the whole thing. So what I'm going to use is the short project, the short version, because it only has 29 data sets, and it will import them, interpolate them, and then remove them. So let's move it back over here. And if we come down here to set up the rain editor, this is still also in the book. We want to simulate rainfall, but turn off the time distribution because we want to use the real-time rainfall. So we don't need to set up any of this information. We do want to set up the building rain switch because we typically would have rainfall on the building. Actually, no, we don't even, yeah, let's see. We can set that up. I'll show you why in a minute. The rest of these can be defaulted to 0 or set to 0. And the last thing that you do is import the real-time rainfall data. So you click the button and you set the folder and select it, and it starts the process to interpolate the cells. And if you want to know where you're at in the process, you can kind of just follow and track it by which one of these auxiliary files is being created. And so as you can see, if you have a really, really big project with a lot of data, this is going to be time consuming. So you just want to get it started and then just walk away from it and leave it, and then maybe come check this out every once in a while to see how far along you are. This one won't take that long because there's only 29 of them and it's a small project. So we'll just go ahead and wait for it. And then once it's finished, we'll take a look at the data. Okay, so it says the importing the rainfall data was complete. So I'm going to click OK. And then I'm going to export the project so that we can see this raincell.dat. Now, when you hit the export button in this current version of the plugin, you will not, you don't have a choice. You have to export the raincell.dat file. That's just the way it goes. It's just set up to automatically export it. But it's a really big file, so that's why I like to do the export on the skeleton project, so that I can just then I can just leave this project alone. I don't have to mess with it ever again. So let's select the folder for the export. And then we'll come back to our lesson 5 short version and go to the export folder. And you can see here that we have, first of all, it says that the export was complete. And we have here that we have exported all the files. So in the next version that will be released, you'll be able to select which files you want to export, so you wouldn't have to export raincell.dat every time. So a couple of things about this project. There's no Manning's N. Spatially variable data has not been assigned. It's default data, so you don't have to have that. Topo data, you don't have to have any grid elevation data. It's not required to create this rainfall data, and you don't have to set up the cont.dat. It can be just blank. So all you need is just the grid space, just the grid. And then you get two files when you do the process that you will need for your project. So rainfall.dat and raincell.dat are going to set up for this project. Rainfall.dat is going to be a little bit different. One means that we're using real-time rainfall. This one means that the rain on building switch is on. And these are just dummies. They just holding the place of the data. They do have to be here, but it's not going to use them. And then the raincell.dat data, as you can see, it's got the interval. The time interval is 5 minutes. And it has the total number of data sets. So there are 29 data sets. The start time and the end time that came straight out of our rainfall catalog. I'll show you that right here. If I can pull that over and open the rainfall catalog, you should be able to see 5 minutes, 29 files, and then the start time and end time. And then what you get is a data set for the whole project, repeated 29 times. So give me a second here. I don't want to do that. Let's do this. Let's get this last grid element number down here. It is 53857. And if I put in here 53857 and I click count, it'll tell you that there's 29 of them. And then if you just want to search them, it's not exactly the last number, but it's close enough. You would see that this doesn't get any this specific cell doesn't get any rainfall data until later on in the storm. So just something to think about. Then you can run this. Once you interpolate the full thing, then you can run it. But instead, what we would do is we would take this data, rain.dat and raincell.dat, copy that, and then put it into the actual project. So in this case, it would be, I've got one right here, lesson 3 complete, QGIS lesson 3 complete. And let's see, where are the data files for this? And then I can paste it in here. It will replace the rain.dat. And in the cont.dat, the rain.dat is turned on, so that's perfect. That's exactly the way you want it to be. And then if you ran this, it would run that new rainfall over the project. But of course, there's only a couple of hours of rainfall data, so it doesn't have exactly the full 24-hour data set. So just something to think about. I'm going to take those out and make sure my rain.dat is back in there. Let me see. I have to grab the rain.dat from another one. I think I took those out, but it didn't replace the rain.dat with the Control Z. No problem. The next time I export it, it'll be there. Okay, and that's it. That's how easy it is to set up NexRAD rainfall data. The hard part is getting the data and getting it, in the correct coordinate system. Let's see, one more important note. You don't need our interval started at 5 minutes. You don't need a time equals 0. The engine starts at time equals 0 and uses the interval from 0 to 5 as the first interval. And what it does is it takes that data over that interval, the rainfall data in inches over that interval, and it interpolates it based on the time step. So it interpolates the data based on the time step and the 5-minute interval. So it takes that 5-minute interval, divides it by your time step, which is, converts it to whatever seconds and then divides it by your time step. And then it runs that spatially variable rainfall over your project. And that's it. So I will pause the video and that'll be it. Thank you.